Welcome back. This time I want to talk about a flip-flop toggle, but used to divide. So we can actually have something that is called divide by n, and we can use a flip-flop toggle implementation. So let's suppose that, whoops, this was the previous episode, stuff from the previous episode, so I'm not gonna need that. So, how about that? If we have a series of flip-flop toggle, so we have something like this, right? We have a flip-flop toggle, which is actually connected to our VCC here. So this is our VCC. And of course, we do have the output and we do have the clock here. You can just say this. And of course, we have the clear signal. And just disconnected to ground. And then we use the output from this to do different things. So basically, one is going to be that we're going to analyze the output, and we're going to call this clock divided by 2. I should have I should have left a bit more space here. Anyway, and then this one is going to basically go into another flip-flop toggle. We're going to call T. So this one is going to be connected to VCC as well. And of course, we do have our clear. It's connected to ground. I almost seem like a Chinese talking. Yeah, with the L. That's racist. I shouldn't be saying that. No offense. I have nothing against Chinese people anyway. So I guess it's a bit of stereotypes, you know. Anyway, so we get the output from Q, and we go on to a third flip-flop toggle, where we have the last output that we're going to analyze. And of course, from here, we're going to use this. Oops, I made a boo-boo actually. I wanted to, yeah, let me just fix it. Yeah, and it's not conventional, but still. Let's suppose that we have VCC here. Okay, so, and then we have clear. Yeah, I shouldn't talk when I do this, because, you know, just get a little bit carried away. Okay, so we're basically going to analyze this, which is the output from this, and this, which is the output from this. So we're going to call this clock divided by 4, and this one we're going to call this one clock divided by 8. The reason why I'm saying this is that let's suppose that we have a certain clock, which we're going to call CLK. So we're going to call this CLK. So this is going to be our clock. So it's going to start high, and then it's going to go low, start high, and go high, and go low, and high, and low, and high, and low. Again, and again, and again, and again, and again, and again. So this is essentially what it does. Just go high and low all the time. It's basically the clock, what the clock does. So what happens? Well, if you remember what the flip-flop toggle, so a T flip-flop, does is essentially that it outputs something that has half the frequency of the clock. So what I mean by that is that if we take a look at the output Q, which we call the clock divided by 2, is indeed the clock divided by 2. So let me just, whoops, adjust that. Okay, so we call this clock divided by 2, and indeed it is. So what does it do? Well, whenever the clock is actually high, going high, okay, so it goes high here, it goes high here, it goes high here, and so on. So what happens is that our signal is actually producing something that is the inverse of this. So let's suppose it was high, then we found out here that the clock was going to be high, okay? So it was going to go low, and it wasn't going to update itself till the next cycle, so when the clock was high again. So it was here, and then it goes high, all the way down here, and then it goes low, all the way to here, and then here, and here, and here, and here, here, and here. I should make it smaller, but anyway. So it goes high again, all the way to here, then it goes low again. Yeah, all the way to here where it goes high again, all the way to here where it goes low again, all the way to here where it goes high again, all the way to here and it goes low again, and again, and then it stays high. So this is basically the output of the clock over 2. Now we're going to use the output as the input for the other flip-flop toggle, and the output of this is basically going to be the input of the clock, and the flip-flop toggle is actually connected to VCC. So what's going to happen to this output is that we're going to have the clock divided by 4, because it has already been divided by 2, so by half, and then we're going to divide this one by half, and half. So we're going to get the clock divided by 4. So CLK divided by 4. What do we get? Well, essentially, whenever the clock is actually rising, then it's gonna go and do the inverse. So we're gonna have it say here and here and here and here, well, and here. So what's going to happen is that we're going to have this essentially. So we're going to start high. I'm going to stay high till here, and then we're going to go low, but we're not going to update our status until we reach this. So we go high again, and then we're going to go low again, and then we meet this. I'm going to go high again, then we stay high till here where we go low again. Now the last thing, we're going to have a clock divided by 8, which is this one, because we essentially we have the T flip-flop, so flip-flop toggle connected to VCC. We're going to use the output of this, so the clock divided by 4, as the input for the clock of the flip-flop toggle. So the output, which has, we had the input that has been divided by 2, and it has been divided by 2 again, so it's divided by 4, and we're going to divide it by 2 again, because this is what the flip-flop toggle does. So we're going to have the clock divided by 8, and indeed the clock divided by 8 is this. We're basically going to have, okay, at each rising, then it's going to go up. So what do we get is that whenever it goes up, it gets the opposite. It goes to the opposite in the opposite way. So this is this is going up, this is going up. So we start high and we stay high till here, where we go low, and we stay low till here, where we go high. So you can see how we can use a flip-flop toggle to basically has a divide by n element. So we can basically divide the clock by a factor of 2 or 4 or 8 and so on and so forth. We just have to kind of chain those together, so those flip-flop toggle, in order to get the desired output. So yeah, this is yet another way in which you can divide. I actually introduced this now because in the last lecture, well, it's not a lecture, it's just an episode of a course, let's say. So we were talking about dividing, and indeed we can actually divide the clock using a flip-flop toggle this way. So yeah, this is basically how we can do that.